Hello, great souls. Welcome back to this channel. We are still continuing with the fundamental accounting principle, and today we're going to be talking about people arrangements and using counting principle. Okay, so the fundamental accounting principle can be used to determine how many different ways can people be arranged if they were to sit in a row. We can actually use it to calculate that. That can help us to actually, maybe if you want to organize a party or something, to determine how many variation, how many different ways or arrangements you can make if you were to place people in rows. So it's very useful in real life. So in this lesson, we are going to learn about how to calculate different arrangements of people if they are to sit in a row with some given restrictions. So let us start with this example. How many arrangements can you make in order to arrange two people in a row? We have two people, we want to arrange them in a row. 1, 2. So those will represent my chairs. 1, 2. We have two people, we want to arrange them in a row. So how many arrangements can we make? All right. Before determining the total number of arrangements using the fundamental counting principle, let us first do this manually in order for you to understand when we actually use counting principle to determine the answer. All right. Let's say I have this person, a boy and a girl. They're the ones that I want to arrange them in this row. So this is the first arrangement that can be made. A boy can be placed there, a girl can be placed there. Or it can actually be like this. We start with a girl, then followed by the boy. So in total, how many arrangements can be made? There are 2 arrangements that can be made. We can see this is the first one, this is the second one, where a boy starts in the first one, in the first position, girl followed, then a girl starts in the first position, then followed by a boy. So we only have 2 different arrangements that we can make in order to arrange these people in a row. Okay, let us now use the fundamental counting principle to determine how many different arrangements we can make. Okay, remember the fundamental counting principle, or in the fundamental counting principle, we only use the number of choices that we have for a particular option. Okay, we have 2 people. So when answering this question, in the first position, what you have to ask yourself when using fundamental counting principle is how many choices do I have to place people in the first position? So because you have 2 people, it means we have 2 choices in the first position. All right. So when you have placed that 2 choices there, you have used you are saying you have 2 options in the first position. When going to the second position, in this first position, only one person is going to sit, right? And you have 2 people. Only one person is going to sit. How many choices will you be left with in the last position? It's only one option. So in total, this can be written as 2 factorial, which is equals to 2 arrangements, total arrangements that can be made. I hope that is clear. Okay, let us now move to other examples. How many arrangements can be made if 5 people were to be seated in a row? If 5 people were to be seated in a row. We can't do it manually because this will be too long. So we are going to use fundamental counting principle as it is the shortest way to determine the total number of arrangements that we can make. All right, we have 5 people. It means we must have 5 chairs. 1, 2, 3, 4, 5. So what you have to ask yourself, in the first position, how many choices do I have? Because we have 5 people to place in a chair, it means in the first position we have 5 options. The first person can sit, the second person can sit, or the third person, or the fourth person, or the fifth person. So we have 5 choices that we can make in the first position. Okay, when you go to the next chair, in this position, only one person is going to sit. So we must subtract one person from a total of 5. How many are left? We have 4 choices. We can choose from 4 people now in the second chair. Now, 2 chairs have been occupied. From a total of 5 people that we have, how many options will we have? We'll have 3 options. Like that, we'll have 2 options until we have only 1 option left. This is the same as 5 factorial. Sorry about that. 5 factorial. Just press your calculator, 5 factorial, it will give you 120 arrangements that can be made. So if we have 5 people, we can make 120 different arrangements if they are to be placed in a row. So you can see that these 120 different arrangements are going to be very difficult if we are to do it manually. Like to place people manually, we count, it was going to take a lot of time. So the fundamental counting principle is actually the shortest way to determine the total number of arrangements that can be made in particular situation. Let us now move to a much deeper example. How many arrangements can be made if 3 boys and 2 girls were to be seated in a row? Okay, now it's quite a different case, but it's the same one. It's just that they have splitted people into genders, male, female. We have 3 boys and 2 girls that are to be seated in a row. How many chairs do we need if we want to sit these people in a row? So we must know the total number of people that we are to arrange in this row. So we have 3 plus 2, which is 5 people. So how many different arrangements can be made? Simply 5 factorial. This will also give us 120 arrangements. Because we have 5 people to be arranged, we can arrange them in 5 different factorial ways. So that is 120. Okay, let us proceed to the third example. You are given 3 boys and 4 girls. The question says determine the total number of arrangements that can be made if. So now we have some restriction here. We have 3 boys and 4 girls. They want us to determine the total number of different arrangements that can be made given these restrictions. Okay, the first restriction, 3.1, if all boys and girls are to be seated in a row. Okay, if all boys and all girls are to be seated in a row, how many chairs will we need to seat all these people? So we must know the total number of people that we want to arrange. It's 3 boys plus 4 girls. The total is 7 people. So how many different arrangements can we make if we are to sit these people in a row? We will need 7 chairs. So it will basically be 7 factorial ways. Let's use our calculator and see how much we get. There are 5,040 ways in which these people can be arranged. Okay. 3.2. If all girls and all boys must be seated next to each other. So now, this is a different approach from the first one. In this restriction, we are given that all girls and all boys must be seated next to each other. It means girls must be together and boys must be together. Okay, so how do you approach this? Okay, let me just represent boys using B's. B1, B2, B3. We have 3 boys and we have girl 1, girl 2, girl 3, girl 4. We have 4 girls. If all boys and all girls must be seated next to each other, it means that the boys must be together and the girls must be together. How many arrangements can be made? Okay, looking at this, what I've sketched here, it's actually our first arrangement. We can start sitting boys together, then followed by girls together. Or we can actually start sitting girls all together, then followed by boys all together. So we can see there can be 2 arrangements that can be made. So it's actually 2 factorial. This is the first one and this is the second arrangement. Now, remember, inside the boys can be arranged in different ways, right? Remember, if they tell you that all boys and all girls must be seated next to each other, it means the boys must be together and the girls must be together. We just determined part of the arrangement that can be made externally. Like, okay, this is the first one. We can start by boys followed by girls, then start with girls followed by boys. But we know that inside, the boys can sit in different ways. So we just count how many boys are there, then the total number of arrangement is the factorial of that number. So we have 1, 2, 3. So inside, the boys can be arranged in 3 factorial ways. Also, inside, the girls can sit in different ways. How many are there? 1, 2, 3, 4. They can be also arranged in 4 factorial ways. That will give us the total number of arrangements that can be made if all boys and all girls must be seated next to each other. Boys together, girls together. So we actually say, okay, because we have 2 different groups, boys and girls, there are 2 factorial ways here. Then inside, the boys can be arranged in 3 factorial ways. Then girls inside here can sit in 4 factorial ways. So we can actually use a calculator to determine the answer. So it's 2 factorial times 3 factorial times 4 factorial. This will give us 288 different ways or different arrangements that these people can sit. Okay, I hope that was clear. Let's come to 3.3. If all boys, okay, sorry about this, I must have included. If all boys must be seated next to each other, determine the number of arrangements that can be made. If all boys must be seated next to each other, determine the number of arrangements that can be made. So this case is quite different from the previous one, 3.2. This is because in this one, they're saying only all boys must be seated next to each other. It means girls can have seated in different positions like that, but boys must be seated next to each other. It means, let me just represent this by writing boys to show that, okay, here our boys, they're seated next to each other. But the girls can just sit in any position they like. One girl can just come and sit this side. So they can just sit in any position they like. So, but all boys must be seated next to each other. How many different arrangements can be made? So, if you are to calculate the total number of different arrangements in this case, you have to just consider all these boys as one thing. You take them as one thing and you count the total number of people that you have. So if we are taking all these boys here as a single thing, we'll have 1, 2, 3, 4, 5. So we can arrange them in 5 factorial ways. But remember, inside, the boys can sit in different ways, in different arrangement. They can sit in different position inside. So we'll also multiply by the number of arrangement the boys can be arranged inside. There are 3, they can be arranged in 3 factorial ways. So that will give us the total number of arrangements that can be made. 5 factorial times 3 factorial. This will give us 720 arrangements or ways that we can arrange all these people if all boys are seated next to each other. Okay, let me repeat this. If all boys must be seated next to each other, you just take them as one thing, then you count how many people are you to arrange. 1, 2, 3, 4, 5. So it's 5 factorial. Don't forget to go inside. Inside, the boys can be arranged in 3 factorial ways. Then it will give you 720. Let's go to 3.4. I also forgot to include all. If all girls must be seated next to each other, determine the total number of arrangements that can be made. So now they're saying if all girls are to be seated next to each other, it means we just place the girls next to each other. The girls are together. Boys can just be seated anyhow they like. So if all girls must be seated next to each other, it's the same as 3.3. We take all these people as one thing, then we count how many people are we to arrange. It's 1, 2, 3, 4. So it will be 4 factorial. Remember, don't forget to go inside. Inside, the girls can sit in many different ways. So we just count how many there are inside. 1, 2, 3, 4. They can also be arranged inside in 4 factorial ways. So we just use a calculator, then determine the answer. So it will give us 576 ways to arrange these people if all girls were to be seated next to each other. Let us lastly look at this one, 3.5. If boys and girls must be seated in alternate positions, how many different arrangements can be made? If boys and girls must be seated in alternate positions, how many different arrangements can be made? Okay, what does it mean when we say boys and girls are to be seated in alternate position? What it means is that we can actually have a boy being seated in that position, followed by a girl, followed by a boy, followed by a girl, followed by a boy, like that. Or we can actually start with a girl, followed by a boy, a girl followed by a boy, a girl followed by a boy, in that manner. So that's what it means if boys and girls must be seated in alternate position. Start with the boy followed by girl, boy, girl, boy, girl, or girl, boy, like that. So, okay. So when answering this question, you must be very careful. Okay. The only way to seat people in alternate positions is to start with the ones that has a higher number. What does it mean? Okay, look, we only have 3 boys, boy 1, boy 2, and boy 3. And we have 4 girls, girl 1, girl 2, girl 3, girl 4. The only way that these people can be seated in alternate position is when we start with a girl, then followed by a boy, girl, followed by a boy, girl, followed by a boy. Am I right? No. Sorry about this. No. That's not possible. Because if we start with a girl, it will be girl, boy, girl, boy, girl, boy. You see, we have already used our 3 boys. So Yeah, it's correct. It's correct. It's correct. Sorry about that. It's correct. So the only way to seat people, these people in alternate position, you start placing those ones with a higher number. So in order to be alternate, because if we start with boys, if you say I'm going to start with a boy, followed by a girl, boy, followed by a girl, boy, followed by a girl, you are left with girl 4. Where will you put her? So you see, if you just come and put her there, it won't be alternate because you have girl girl, so they're not sitting in alternate position. So that's why we have to start with the one that has a higher number. So in order to sit them in alternate position, we must start with girls. So it must be a girl, boy, girl, boy, girl, boy, and a girl. So you can see all of them are seated in alternate positions if you look here. So how do we determine the total number of different arrangements that we can make? That's an important question. So in order to determine the total number of arrangements that can be made, what you do is you come here and make the total number of people that you want to arrange. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we know that here there must be a girl. Here there must be a girl. Here there must be, okay, alternate girl. Here there must be a girl. So girls can be placed in 1, 2, 3, 4, right? So there are how many ways to arrange girls? There are only 4 factorial ways. Then when you come with the boys, boys can either sit here, here, or here. So it's 1, 2, 3. So they can be seated in 3 factorial ways, or they can be arranged. We have 3 boys. So in this position, we can choose from 3 boys. We can either place boy 1, we can either place boy 2 or boy 3. So we have 3 choices. When we come here, how many choices do we have? We have 2 choices because we have used 1 boy there. So we are left with 2 boys to choose from in that position. Then we'll have 1 choice there. So that's why we're saying there are 3 factorial ways to arrange them. So that's how you actually determine the answer of that. So it will be 4 factorial multiplied by 3 factorial, which will give you 144 ways in which you can arrange those people. Thank you very much for watching. Make sure you subscribe. I'll put down the link for the other videos. If you missed counting principle part 1, part 2, and part 3, this is part 4 where we were talking about how to arrange people using fundamental counting principle, actually how to calculate the number of different arrangements that can be made. Thank you very much for your time. Have a nice day. Thank you.